Okay, this is going to be a quick video talking about how to name covalent compounds, okay, specifically binary covalent compounds. So we're talking about binary covalent compounds here, all right, and bi, right, bi means two, so binary means there's two elements in your covalent compound, in your covalent molecule. Okay, so really there's only 3 rules to follow, and rule number 1 we will talk more about later, and or you can just kind of look up this number in your periodic table, okay? So your most electronegative element is listed last. Okay, so your most electronegative element goes at the end. Then naming gets really easy, okay? Because for your first element, all you do is you have a prefix plus the name of the element itself, okay? And this is the part that confuses everyone when we start talking about covalent naming, okay? Because you do not have prefixes in ionic naming, but you do have prefixes in covalent naming, so watch out for that. The only little exception to the rule with the first element is mono, okay? You don't ever start something with mono. We'll look at examples of this. And then last step is for your second element, you have a prefix plus the name that ends in "ide", okay? So just like an ionic compound, you're gonna change its last name to "ide". And that's it. Okay, so let's actually do some examples. All right, so you are actually going to have to learn your prefixes, okay? And I'm gonna separate them out kind of funny, all right? You will need to know numbers 1 through 10. 1 through 4 are the tricky ones to remember. 5 through 10 are the easy ones to remember because these are the same numbers you've had in geometry, okay? So if you have a quantity of 1 of an element, it's going to be mono. 2 is di. 3 is tri. 4 is tetra. Okay, and now beyond mono, di, tri, tetra, it's just geometry. Okay, so a 5-sided figure is a pentagon, pent. 6 is a hexagon, so hex. 7 is a hept. Okay, please make sure for 7, I don't know why every year I get people saying sept. That's not a thing. No, okay? So I don't know where that comes from. I don't know if that's, I don't know, but every year I get someone saying sept. So no, it's hept, okay, with an H. 8 is oct, like an octagon. 9 is a nonagon, and 10 is a decagon. I guess all these actually end in A, right? Hexa, hepta, octa, nona, decagon. Okay. So here are your prefixes 1 through 10, and you're going to need to know those for actual examples, all right? So definitely you're going to need to know these. You will need to memorize these. They'll need to be ingrained in your brain. So pause the video, write them all down, do something, okay? You'll need these. On we go, all right? Okay, so I actually love the example that your book gives for this because they list a bunch of different nitrogen and oxygen compounds, okay, molecules that you have to name, all right? And we follow the rules, okay? So most electronegative goes last, who cares? They've already made the compounds for you, okay? Oxygen is more electronegative than nitrogen. You don't really need to worry about that now, just oxygen is the last one, cool. All right, so to actually name them, it's basically gonna be these 2 rules right here. Okay, these 2 rules are to name, all right? So for my first element, I just have the prefix and the name, but don't have mono if it starts with mono. So N, there's only one N, So that would be mono, but I don't start a compound with mono ever. So, you know, if I was writing it out, it would be mono nitrogen, and then only one oxygen, so mono oxide. I'm doing this wrong on purpose, okay? So if it's my first element, I don't include mono, so that mono goes away. So not mononitrogen, just nitrogen. And then this double O in the middle for monoxide looks dumb and awful. So we don't double up the O's. All right, so just get rid of one of those O's. So this would be nitrogen monoxide. Nitrogen monoxide, okay? Next, NO2, one nitrogen. So again, mononitrogen, right? I don't change the ending. Oh, I didn't even mention that, right? So this one, instead of saying oxygen, monoxygen, right? I end in "ide", so monoxide, okay? My bad. All right, then this one, right? Mononitrogen, and this is now two oxygens. So it's gonna be di, and then oxygen becomes oxide, okay? Mononitrogen dioxide, but this starts with mono. I don't ever start something with mono. Bye-bye mono. So this is just nitrogen dioxide. Now I have this, two nitrogens. So dinitrogen, two oxygens. Dioxygen, but I need to end in "ide", so dioxide. Okay, dinitrogen dioxide. Next, two nitrogens again, so dinitrogen. Remember, I don't change this to "ide", right? My first element just gets its regular old name, no ending change, okay? So dinitrogen, now it's three oxygens. So tri-oxide. Another di, okay, so dinitrogen again, and now it's four oxygens. So four is tetra. This will be tetra oxide. And last but not least, trinitrogen, because it's three nitrogens. Five is like a five-sided figure, right? The pentagon. Penta. Oxide. But again, this AO looks stupid. So pentoxide. Okay, so it's just pentoxide per penta. I would never mark you off if you left in the A and said pentaoxide. I mean, that to me, hooray. Okay, you get the concept. All right, so technically, right, if we are following all the rules, this lovely molecule would be dihydrogen, one oxygen, so this would be monoxide. But monoxide sounds stupid, so we would just say monoxide. Okay, but we don't call this dihydrogen monoxide. We, of course, call this water. Okay, there are some binary molecules that are so familiar and just, you know, kind of very common that we use their common name instead of their technical name, right? Dihydrogen monoxide, all right? CH4, in this case, this would be monocarbon, but I never start with mono, right? So this would just be carbon with four hydrogens. So tetrahydride, right? Ending in "ide. But I don't actually use this name. I would instead use methane. Okay, this is CH4 is actually the gas that like comes out of your stove if you have a gas stove top and you go and, you know, need to cook on your stove, boil some water or do something. CH4 is methane. That's what comes out of your stove, okay? And we would call this methane, not carbon tetrahydride, all right? NH3 would be mononitrogen, but again, no mono to start with, so just straight nitrogen. 3 hydrogens would be trihydride. Okay, would be its technical name, but we call this ammonia. All right, that's a cleaning product. Okay, also in cat pee. So if you have cats and you ever have to like sift out their litter box and you have that horrible smell, congratulations, that's what you're smelling. Okay, and then this lovely guy, 2 hydrogens would be dihydrogen. 2 oxygens would be dioxide. Okay, is its technical name, right? Dihydrogen dioxide, that would be named correctly. But we call this just hydrogen peroxide. Okay, so if you went to, the pharmacy and picked up that little brown bottle of hydrogen peroxide that you put on like a cut or something that you have and it bubbles up, that's what this is. It's H2O2, hydrogen peroxide. It's its common name for it. So just be aware. There are other ones that are like this, but these are the 4 kind of common ones that I can think of that you want to know they're more used names than like, we're never going to say this is dihydrogen monoxide, right? So, okay, other than that, you should be able to just kind of follow your prefixes and answer any covalent molecule naming questions, okay? What I definitely want you to do, and that's what's going to be in this week's kind of homework packet, okay? There's going to be some that are like some pages that are just covalent naming, but there's going to be some pages that are covalent and ionic naming, okay? Because once you learn prefixes, here's what ends up happening, okay? You've gone through and you've done a bunch of prefix questions with covalent stuff, and then you get this, okay? So after you've done your covalent naming, then you come across this and you're like, oh, this is going to be iron monoxide. And this will be diiron trioxide. Okay? I promise you I'm going to have someone do this, and don't do this. Don't let this be you. Please remember that your prefixes are only for covalent compounds. If you see a metal, boom, that's a metal, okay? You know this is ionic, which means you have to go by the ionic naming rules, okay? No prefixes for these guys. So this would be, the O has a 2-, which means this iron must have a 2+. So this should be iron 2 oxide. And in this case, there's 3 oxygens. Each one has a 2- charge. So 6- total from here. To get 6+ total from here would mean that each iron would need a 3+ charge because there's 2 of them. So this would be iron 3 oxide, okay? None of this diiron trioxide nonsense, okay? So I really want to just, hammer it into your head, all right? Please, your prefixes go with your covalent stuff. Don't let that affect how well you're doing with your ionic stuff, okay? Because I know you're acing ionic stuff right now. So just be careful. That is definitely what's going to be on this week's homework is kind of practice initially with just covalent stuff, making the correct compounds and naming them correctly. But then I want you basically to, review and try to not confuse yourself with covalent naming structures versus ionic naming structures. Okay, good luck.